My name is Brechtje van Wezenbeek and I work for Deltares and the Delft University of Technology. I have a background in ecology with a PhD on salt marshes and I work mostly on building with nature projects with a focus on knowledge development. I will introduce you to some ecological principles that will help you in your building with nature designs and in your understanding of natural processes and ecosystem functioning. In nature, things are not always what they appear to be. You think this is a pond, but possibly this used to be a stream. You think this is a salt marsh, but it may also be just another phase of an intertidal flat. Organisms that have the capacity to substantially change their surroundings are called ecosystem engineers in ecology. In a paper in 1994, Jones and others described ecosystem engineers as species that modify their surroundings. For example, a beaver is able to change a flowing river into a stagnant pond, thereby creating a whole new ecosystem. An intertidal flat can become a salt marsh once it is high enough to be colonized by marsh grasses, such as English cordgrass. These grasses can't grow if they are submerged for too long, as they need sufficient light to perform photosynthesis. However, once an intertidal flat becomes high enough and submergence time low enough, which generally is around mean high tide, these grasses can establish. Once they have established, they still get submerged twice a day. When they do, they reduce current velocities and so enhance precipitation of sediment. This increases their elevation, which means that their submergence time is reduced and they have more time for photosynthesis. This is beneficial for them and enhances their growth. More biomass will also increase their trapping capacity. These positive effects that enhance each other we call a positive feedback. The positive feedback between cordgrass and sedimentation sets off salt marsh formation. A salt marsh grows to fill the accommodation space and so its height depends on the tidal amplitude. In the Western Scheldt, salt marshes in front of the levee can become almost 4 meters above mean sea level, a lot higher than the polders that are behind the levee. Now you have already learned some important ecological concepts, such as ecosystem engineers and positive feedbacks. In this video, I will teach you some more. Your knowledge of these generic ecological concepts will help you in making better building with nature designs. But always get an ecologist with local expertise to help you. For building with nature solutions, the ecosystem or natural process forms an essential part of the design. Ecosystem refers to the community of living organisms and environmental characteristics that interact with each other through nutrient cycles and energy flows. Examples of ecosystems are salt marshes and intertidal flats, which I mentioned before, but also coral reefs, for example. Building with nature solutions can include a naturally present ecosystem and then aim to conserve and manage that ecosystem for its function. However, if an ecosystem is degraded or lost, the building with nature solution can aim for recovery or restoration of the ecosystem. Basically, ecosystem restoration focus on restoring abiotic conditions in such a way that ecosystems can re-establish naturally or will be aided in their recovery. What do I mean by conservation and restoration in the context of building with nature? For instance, in Indonesia, mangrove forests are removed for fish and shrimp farming. This makes coastal communities vulnerable to flooding. By conserving a stretch of mangrove forest and by putting a small earthen levee behind it, people are safer and the mangrove is conserved as a component of a mangrove levee coastal defense strategy. Restoration comes into play when the mangrove has already been destroyed. Then you need to rebuild it to implement the mangrove levee combined defense strategy. Restoration draws strongly on other ecological concepts, such as ecosystem functions. The most important aspect of an ecosystem in a building with nature design is the functions it has to offer. Ecosystem functions that are beneficial to humans we call ecosystem services. A service is what humans value, but here we will talk about ecosystem functioning and its intrinsic value. We as humans are with many, but we constitute only a small part of the vertebrates. The vertebrates, in turn, only constitute 2% of all animal species on the world. For good ecosystem functioning, we need many of these organisms. We need the plants as the primary producers, and we need the species that eat the primary producers, herbivores. We need the big predators to control the size of the herbivore populations. But we also need the community of bacteria and little worms in the soil that prepare the environment for the plants. This structure of different species that feed on each other is called a food web. To summarize, you have seen that ecosystem engineers can heavily affect their surroundings, that positive feedback loops and interactions between organisms and abiotic parameters can set off landscape formation. Building with nature solutions work with these aspects to aim at conservation or restoration of ecosystems for functional purposes. So how do we enable an ecosystem to perform desired functions? We have to take care that the external conditions that we can influence are optimal for the development of healthy, biodiverse and resilient ecosystems. Only then can the ecosystem perform the desired functions to an optimal extent. I will tell you all about this in the next video.